So what is up everybody? My name is Megan Dominic M. Paderon, BSMT from NJ2A3. So for today's video, I'm going to discuss and explain the different data communication and network devices. So let's start. The first one on our network devices are the switches. A switch is a multi-port device that improves network efficiency. The switch maintains limited routing information about nodes in the internal network, and it allows connections to systems like hubs or routers. Using switches improves network efficiency over hubs or routers because of the virtual circuit capability. Switches also improve network security because the virtual circuits are more difficult to examine with network monitors. You can think of a switch as a device that has some of the best capabilities of routers and hubs combined. A switch can work at either the data link layer or the network layer of the OSI model. The next one is the bridges. Bridges are used to connect two or more hosts or network segments together. The basic role of bridges in network architecture is strong and forwarding frames between the different segments that the bridge connects. They use hardware media access control or MAC addresses for transferring frames. Bridges work only at the physical and data link layers of the OSI model. Bridges are used to divide larger networks into smaller sections by sitting between two physical network segments and managing the flow of data between the two. Bridges are like hubs in many aspects, including the fact that they connect LAN components with the identical protocols. However, bridges filter incoming data packets known as frames for addresses before they are forwarded. Next are the gateways. Gateways perform all of the functions of routers and more. In fact, a router with added translation functionality is a gateway. The function that does the translation between different network technologies is called a protocol converter. Gateways normally work at the transport and session layers of the OSI model. At the transport layer and above, there are numerous protocols and standards from different vendors. Gateways are used to deal with them. Gateways provide translation between networking technologies such as Open System Interconnection or OSI and Transmission Control Protocol or Internet Protocol or TCP or IP. Next are the routers. Routers are intelligent devices and they store information about the networks they're connected to. Routers help transmit packets to their destinations. Charting a path through the sea of interconnected networking devices uses different network topologies. Routers, in conjunction with a channel service, unit data service, or CSU or DSU, are also used to translate from LAN framing to WAN framing. This is needed because LANs and WANs use different network protocols such as routers are known as border routers. They serve as the outside connection of LAN to WAN and they operate at the border of your network. Next is the backbone. A backbone router is a router designed to be used to construct backbone networks using leased lines. Backbone routers typically do not have any built-in digital dial-up wide area network surfaces. It provides a path for the exchange of information between different LANs or sub-networks. A backbone can tie together diverged networks in the same building, in different buildings in a campus environment, or over wide areas. Normally, the backbone's capacity is greater than the networks connected to it. Now let's proceed to wired network communication media. The first one is the twisted pair wire. The most popular form of communication media is the twisted pair wire. Two isolated copper wire isolated in a spiral. It is relatively easy to set up a network using twisted pair cable, although it is commonly used medium. A single twisted pair cable is capable of providing a capacity up to 1 Gbps for short distances, typically not more than 100 to 200 meters. It can handle up to 62 kb per second. Twisted pair makes the world's public telephone line communication. Next is the coaxial cable. A coaxial cable is a type of shielded and isolated copper cable that is used in computer networks and to deliver cable TV services to end users. It was first commercially implemented in the early 1940s, and it is used for both baseband and broadband data communication services. Coaxial cable is also known as coax, which is derived from the geometric axis created between a shield and isolator. A coaxial cable is used by the cable TV service providers to stretch transmission lines from their branch or control offices, residential, and business subscribers. Next is the fiber optic cable. A fiber optic cable is a network cable that contains strands of glass fibers inside an isolated casing. They're designed for long distances, high-performance data networking, and telecommunications. Compared to wired cables, fiber optic cables provide higher bandwidth and transmit data over longer distances. Fiber optic cables support much of the world's internet, cable television, and telephone systems. A fiber optic cable consists of one or more strands of glass, each only slightly thicker than a human hair. The center of each strand is called the ore, which provides the pathway for light to travel. The ore is surrounded by a layer of glass called cladding that reflects light inward to avoid loss of signal and allow the light to pass through bends in the cable. Now let's proceed to the wireless communication media. The first one is the infrared transmission. Infrared transmission refers to energy in the region of the electromagnetic radiation spectrum at wavelength longer than those of visible light but shorter than those of radio waves. Correspondingly, infrared frequencies are higher than those of microwaves, but lower than those of visible light. Infrared technology uses diffuse light reflected at walls, furniture, diffuse light reflected at a directed light. If a line, a site, LOS, exists between sender and receiver, in infrared transmission, senders can be simple light emitting diodes or LEDs or laser diodes. Photodiodes act as receivers. Next is the broadcast radio. Radio broadcasting is the transmission of audio or sound, sometimes related with metadata, by radio waves intended to reach a wide audience. In terrestrial radio broadcasting, the radio waves are broadcast by a land-based radio station, while in satellite radio, the radio waves are broadcast by a satellite in Earth's orbit. To receive the content, the listener must have a broadcaster radio receiver or radio. Stations are often affiliated with a radio network which provides content in a common radio format, either in broadcast syndication or simulcast or both. Next is the cellular radio. Cellular radio describes a method of increasing the number of simultaneous radio conversations that can be supported by a fixed number of radio frequency or RF channels by limiting the range of transmitters to a single cell to which a proportion of the available channels is allocated. Cell phones use radio waves to communicate. Radio waves transport digitized voice or data in the form of oscillating electric and magnetic fields called the electromagnetic field or EMF. The rate of oscillation is called frequency. Radio waves carry the information and travel in air at the speed of light. Next is the microwave radio. Microwave radio transmission is commonly used in point-to-point communication systems on the surface of the Earth. In satellite communication and in deep space radio communication, other parts of the microwave radio band are used for radars, radio navigation systems, sensor systems, and radio astronomy. Last but definitely not the least is the communication satellites. A communication satellite is an artificial satellite that relays and amplifies radio telecommunication signals with a transponder. It creates a communication channel between a source, transmitter, in the receiver at different locations on Earth. Communication satellites are used for television, telephone, radio, internet, and military applications. Satellite communications play a vital role in global telecommunication system. Approximately 2,000 artificial satellites orbiting Earth relay analog and digital signals carrying voice, video, and data and from one of many locations worldwide. That's all for today's video. I hope you guys learned something and thank you for watching.